new tool in Eclipse. Focusing on new tool. The platform also provides useful building blocks and frameworks that facilitate developing new tools. Now we are considering launching a program in program debug and launch support. The platform debug plugins allows your plugins to extend the platform so that your particular type of program can be launched from the workbench, obtaining input from the user if necessary. A unique type of program can be launched in the platform is called launch configuration type. The class iLaunch configuration is used to describe a type of configuration. A launch configuration keeps a set of named attribute that can be used to store data specific for a particular kind of launcher. For each configuration type, there are different modes in which the configuration can be launched. The platform defines modes for running, debugging, or profiling program defined by a particular configuration. Plugins are free to implement any of all these launch modes for a particular launch configuration or define new launch modes for any launch configuration. Plugins that contribute additional types of launchers do so by providing iLaunch configuration delegate or iLaunch configuration delegate 2 that knows how to launch program given in the expected type and mod for launch configuration. Once the program is launched, an iLaunch object is used to represent the launch session. This object can be queried for information such as running processes, debug session information, and store code location. Or launch knows the configuration that was used to create it. Users interact with the launch configuration dialog to set up the parameters for different types of launchers. This configuration can be stored in a file to be shared with other users or stored locally in the workspace. Here the interface iLaunch configuration. A launch configuration describes how to launch an application. Each launch configuration is an instance of a type iLaunch configuration as described by the launch configuration type extension. Each launch configuration has a launch configuration delegate which performs actual launching of a configuration. Now this interface iLaunch configuration delegate a launch configuration delegate perform launching a specific type of launch configuration. A launch configuration delegate is defined by the delegate attributes of a launch configuration type extension. iLaunch configuration delegate 2 optional enhancement to launch configuration delegate interface which allows launch delegates to abort a launch, build relevant projects in a workspace before launch, and create a launch object to be used in a launch. Interface iLaunch. A launch is a result of launching a debug session and or one or more system processes. Here you can see file or workspace data. And here you can see iLaunch configuration, name, location, attribute name value, and iLaunch configuration interacts with iLaunch iLaunch configuration. Launch iLaunch configuration is connected to iLaunch configuration delegate. iLaunch configuration delegate is connected to iLaunch processes debug target source locator. iLaunch is connected to iLaunch configuration. Some sample we can consider this. This is in plugin.xml. Plugin.xml defined extensions that this plugin provides extension points are how Eclipse advertises the plugin extensions, much like USB Hub provides a generic connector that allows many other types of devices to be plugged in. The Eclipse extension points are documented in the help system, and each has a point identifier with optional children that are point specific. In this case, the extension is defined using the org.eclipse.ui.views point, which expect a combination of category and view elements. So this will look like this here. The class in this case extends the viewPart abstract class, which is used for all views in Eclipse 3.x. The Eclipse 4 model defines views in a different way. And Eclipse 4.x SDK include the 3.x compatibility layer, so this example will work in Eclipse for Eclipse 4.x SDKs. Here we can consider drawing a custom view. For the extension in plugins, an SWT canvas can be used to provide custom rendering for a view. As a starting point for drawing the clock, the canvas will use draw arc to create a circle. And step 1, remove the content of clock view, leaving behind an empty implementation of the set focus, and create part control methods. Then step 2, run the target Eclipse instance and see that clock view is now empty. Step 3, in the create partition control method, do the following. Step 1, create new canvas. Step 2, add paint listener to canvas. And step 3, get GC from paint event. And call draw arc to draw a circle. So code will look like this. And run the Eclipse instance and show the clock view. Then resize the view, and clock should change size with it. Here we can, as an example too, here we consider how to open plugins in Eclipse. Plugins for The open source IDE Eclipse let you use pre-built function in your own development projects. You can download plugins from the internet or create your own for later use. To open plugins in your Eclipse project, you import them into the project from their location on your hard drive or an Eclipse platform. Here, step 1, click the file menu, select import. Step 2, click plugin development and plugins. Step 3, click the radio button under import from and choose which option you want, the current platform, a different platform, or your hard drive. Step 5, click the plugins you want to open to select them. Step 5, select an option under import as and determine what from the plugin should have. Click OK. As an error example, we can consider this plugin load error, java.lang.nullPoint exception. This is end of my presentation. Now we are considering platform architecture, platform SDK roadmap in platform plugin developer. Java development tools JDT. The Java development tools JDT plugins extend the platform workbench by providing specialized features as for editing, viewing, compiling, debugging, and running Java code. JDT is installed as a set of plugins that are included in SDK. The Java development user guide describes how to use the Java tools. The JDT plugin developer guide describes the structure and API of the JDT if you refer the documentations. Now we are considering a minimal plugin in a simple plugin example. We all know that Hello World looks like in a plain old Java without using any user interface frameworks or other specialized library. What happens to this old standard in the context of Eclipse platform? Instead of thinking Hello World as a self-contained program, we can recast it as an extension of the platform. Since we want to say Hello World to the world, we need to configure out how to extend the workbench to include our greeting. When we get deeper into the platform in user interface component, we will do an extensive review of the ways we can extend and customize your workbench UI. For now, let's start with one of the simplest workbench extension, a view. We can think of a workbench window as a frame that represents various visual parts. These parts fall into major categories: views and editors. We look at editors later. Views provide information about some object that user is working with the workbench. Views often change their content as the user select the different objects in the workbench. Here you can see a Hello World view. Now we have after creating the project package and a view class for our plugin, we are ready to study some code here. Here's everything you need to your Hello World view. Copy the contents below into the class you created, replacing the auto-generated content. The view part creates the widgets that will represent the in the create part control method. In this example, we create an SWT label and set the Hello World text into it. This is about simplest view that can be created. Set the focus to my widget. For label, this doesn't make much sense, but for the more complex sets of widgets, you would decide which one gets the focus. Now we are considering extension points and the registry in runtime plugin model and runtime overview. The Following code is a simplified snippet based on the workbench implementation of the show view dialog. The interface I extension registry. The extension registry holds the master list of all discovered namespaces, extension points, and extensions. The interface I extension point, an extension point declared in the plugin, except for the list of extensions plugged into it. The information available for extension point is obtained from the declaring plugins manifest plugin.xml file. These are in the package org.eclipse.core.runtime. While the bundle aspects of a plugin may be interesting to the runtime plugin and runtime tools, it is much more common that the plugin is concerned with what extension point have been defined in the plugins and what extensions are contributed by the plugins. This information is provided by the plugin extension registry, I extension registry. Why might a plugin want to know what extensions are present? A concrete example will help show the need for this information and protocol for getting it. Recall the workbench show view dialog, which all the available views that have been installed in the platform. We know that the category names and the view names all contributed views are specified in the plugin.xml file for a plugin, for any plugin that contributes an extension for org.eclipse.ui.views. But how does the workbench find out this information from the platform extension registry? The following code is a simplified snippet based on the workbench implementation of show view dialog. We see above that the registry can be obtained from the platform class. The protocol I extension registry is used to find extension point named org.eclipse.ui.views. Information in the registry about particular extension points or extensions can be found in the protocol defined in I extension registry. I extension point and I extension. Javadoc for these classes provides details information about registry protocol. Once the extension definition of interest has been found, the protocol I configuration element can be used to examine the individual attributes of an extension. Get the information about each extension. Now we are considering org.eclipse.ui.views in basic workbench extension point using commands in plugin into the workbench. Identify org.eclipse.ui.views This extension point is used to define additional views for the workbench. A view is usual component within a workbench page. This is typically used to navigate hierarchy of information like the workspace, open an editor, or display properties for active editor. The user can make a view visible from the window, then show view menu, or close it from the view local title bar. A view is a workbench part that can navigate a hierarchy of information or display properties for an object. Only one instance of any given view is open in a workbench page. When a user makes selections or other changes in a view, these changes are immediately reflected in the workbench. Views can often provide a support for corresponding editor. For example, an outline view shows structured view of the information in an editor. A properties view shows the properties of an object that is currently being edited. An extension point org.eclipse.ui.views allows plugins to add views to the workbench. Plugins that contribute a view must register the view in their plugin.xml file and provide configuration information about the view, such as implementation class, category or group, category or group of views to which it belongs, and the name and the icon that should be used to describe the view in menus and labels. The interface for views defined in iView part, but plugins can choose to extend view part class rather than implement an iView part for Scratch. We implement a minimal view extension in the Hello World example. Now we will look at the ones that aware of the other workbench views, respond to user navigation and selection changes in the workbench. First, let's look at the declaration of an extension in plugin XML. This would look pretty familiar, and we see that a new window info view is contributed to the workbench. View ID, name and category are specified as we've seen before. Let's look at the view info. You can show any view in the workbench by choosing window, then show view, then other, selecting the view from the show view list. When we show the info view, the view with the list of listed pop-ups, the list is pre-populated with some data. We will start with get familiar with create part control method. As we saw in the Hello World example, this is where the widgets that represent a view are created. We will ignore some of the code that get started. View creates and stores a list viewer. And sets the content and label providers. It also registers itself with the selection provider label provider, and content provider come from JFace viewers. It obtains the service from its iView site. Which contains information about the view context, such as workbench window. It's containing page, its local services, and its plugin. We have covered a lot of common workbench concept by studying this extension here now. Service will be providing our input. Register myself as selection provider for this view. Now we are considering standard dialogues in wizards and dialogues and wizard. The standard dialogues are designed to are designed so that you can completely specify the dialogue in its constructor. We show a message dialogue in action in the readme tools view action. The class message dialog, a dialog for showing messages to the user. This is in the package org.eclipse.jface.dialogs. The package org.eclipse.jface.dialogs defines a basic support for dialogues. This package provides standard dialogues for displaying user messages and obtaining simple input from the user. Message dialog displays the message to the user. You can set the dialog title, image, button text, and messages in the constructor for this dialog. You can set the message. Yep. Error dialog displays the information about an error. You can set the dialog title and the message for the dialog. You can also supply IS status object which the dialog will use to obtain an error message. Input dialog allows the user to enter text, and you can set the dialog title, default text value, and the supply an object that will validate the text input. Progress monitor dialog shows the progress to the user during the running of the long operation. The standard dialogs are designed so that you can completely specify the dialog in its constructor. We saw message dialog in action in the readme tools view section. Here you can see the dialog, open information, and etc. Now we are considering viewers in JFace UI framework. We first show the viewer in its readme tools view contribution inside the readme section view. Class list viewer, a concrete viewer based on an SWT list control. This is in the package org.eclipse.jface.viewers. Why would you ever want to use a viewer when we already seen that the workbench UI contributions like views, editors, wizard, and dialogues can be implemented directly with SWT widgets. Viewers allow you to create widgets while still using your model object. If you use an SWT widget directly, you have to convert your objects into strings and images expected by SWT. Viewers act as an adapter for on SWT widgets, handling the common code for handling widget events that you would otherwise have to implement yourself. We first show the viewer in the readme tools view contribution inside the readme section view here. We can see that. Note, viewers can be used to provide implementation for both workbench views and editors. The term viewer does not imply that they are only useful for implementing views. For example, text viewer is used in the implementation in many of the workbench plugin editors. Now we are considering widget application structure in widgets in standard widget toolkits. Since the application only displays the string hello world, it does not need to register any widget events. The class label instances of this class represent a non-selectable user interface object that displays a string or image. When separator is specified, displays a single vertical or horizontal line. This is in the package org.eclipse.swt.widgets. When you are contributing UI element using platform workbench extensions, the mechanics of starting up SWT are handled for you by the workbench. If you are writing an SWT application from scratch outside of the workbench, you must understand more about SWT's application structure. A typical standalone SWT application has the following structure. Create a display which represent SWT session. Create one or more shells which serve as the main windows for the application. Create any other widgets that are needed inside the shell. Initialize the sizes and other necessary states for the widgets. Register listeners for widgets events that need to be handled. Open the shell window. Run the event dispatching loop until the exit condition occurs, which is typically when the main shell window is closed by the user. Dispose the display. The following code snippet is adapted from the org.eclipse.swt.examples.helloworld.helloworld2 application. Since the application only displays the string hello world, it does not need to register for any widget events. Now we are considering form control in UI in controls in UI forms. For example, consider the following code snippet. The class form form is a custom control that renders a title and optional background image above the body composite. It can be used alone when a part of parents that are scrolled. Scrolling is required. If scrolling is required, use scrolled form instead, because it has an instance of form and adds a scrolling capability. This is the form is in the package org.eclipse.ui.forms.widgets. Form is a basic control used to host UI forms. It provides settings for a title and scrolling the content similar to the web browser. What makes the forms appealing is the fact that the content is an SWT composite that can be used as you would use it in the other context. For example, consider the following code snippet. UI forms manipulate SWT widgets in number of ways in order to achieve the desired effect. For that reason, controls are typically created using form toolkit. Normally, an instance of scrolled form is created in order to get the scrolling. When forms need to be nested, form instance provide everything except for scrolling of the form content. Form get body form content is rendered below the title. SWT widgets are created in the form using form.getBody as a parent. The constructor. This is a callback that will allow us to create a viewer and initialize it. Passing the focus request to the form disposes the toolkit. Now we are considering creation of a common navigator view in step-by-step instructions in Common Navigator framework. The example plugin org.eclipse.ui.examples.navigators.resources shows this. The class Common Navigator. This class provides the iView part for the Common Navigator framework in the Eclipse workbench. This class also serves as the backbone for navigational viewers. The following types are used by this class to render the Common Navigator. Common Viewer, the viewer that renders the extensible tree, creates and manages the lifecycle of the Navigator content service. Navigate Action Service manages the instance of common action providers provided by individual extensions and content extensions. iNavigator Content Service manages instances of Navigator content extensions. Instances are created as needed and disposed of upon the disposal of the Navigator Content Service. This is in the package org.eclipse.ui.navigator. In order to use CNF based view in the application, several steps are required, which are discussed now. The created view can be configured by binding specific contents and action to it, which the example plugin org.eclipse.ui.example.navigators.resources shows this. The first step 1, add the following dependent plugins. Add the viewer extension org.eclipse.ui.views and provide the org.eclipse.ui.navigator.common navigator as the value of the class attribute. Please note that the ID view will be required in later steps for the content and action bindings. Please note, if you are defining your own perspective in which Common Navigator is used, show title parameter must be set true in order the viewer renders correctly. True show title. Now we are considering resources and the file system. In resources overview, interface iWorkspace. Workspaces are the basis for Eclipse platform resource management. There is only one workspace for running platform. All resources exist in the context of this workspace. This is in the package org.eclipse.core.resources. when a platform is running and the resources plugins is active, the workspace is represented by an instance of iWorkspace, which provide the protocol for accepting the resources it contains. An iWorkspace instance represents an associated collection of files and directories in one or more file systems. You can access the workspace from the resources plugin class defined in org.eclipse.co.resources. When the resources plugin is not running, the workspace exists solely in the file system and is viewed or manipulated by the user via standard file-based tools. Let's look at the now we are considering defining a nature in project natures in advanced resource concepts. The following markup adds a nature for hypothetical com.example natures plugin. Identifier org.eclipse.core.resources.natures. The workspace supports the notion of project natures, or natures for short. The nature associates lifecycle behavior with the project. Natures are installed on a per project basis using the set description method defined in the org.eclipse.core.resources.iProject. They are configured when added to a project and deconfigured when removed from the project. For example, Java nature might install a Java builder and do other project configuration when added to a project. The org.eclipse.core.resources.natures extension point is used to add project nature definition. The following markups add the nature for the hypothetical com.example.natures plugin. The class identified in the extension must implement the platform interface iProject nature. The following markups this class implements plugin specific behavior associating nature specific information with the project when nature is configured. The configure and the deconfigure methods are sent by the platform when natures are added and removed from the project. You can implement configure method to add a builder to a project builder for a project. Add nature specific information for the project, such as adding a builder to a project's build spec. Remove the nature specific information here. Writing an undoable operation in undoable operations in advanced workbench concept. Using operations, the execute method is responsible for creating an operation that does the work formally done in the execute method and requesting that operations history execute the operations so that it can be remembered for undo and redo. The interface undoable operation undoable operation defines an operation that can be executed undone and redone. Operations typically have fully defined parameters, that is, they are usually created after the user has been queried for any input needed to define the operation. This is in the package org.eclipse.core.commands.operations. We will start by looking at a very simple example here. Recall the simple example in this is simple example here. It builds a string, and then here we are considering building a string and then open a dialog. That code is omitted here. Using operations, the execute method is responsible for creating an operation that does the work formally one in the execute method and requesting that operations history execute operation so that it can be remembered for undo and redo. The operation encapsulates all behavior from run method as well as the undo and redo for operations. For simple commands, it may be possible to move all the nuts and bolts work into operation class. In this case, it may be appropriate to collapse the former handler classes into single handler class that is parameterized. The handler would simply execute the supplied operation when it is time to execute. This is largely an application design decision. When a command launches the wizard, then the operation is typically created as part of the wizard's perform finished method or wizard's pages finish method. Converting the finish method to use operation similar to converting execute method. The method is responsible for creating and executing an operation that does the work previously done inline. Build the string buff. Build a string buffer buff. Build the string buffer buff. Simply recalculate the delta. Now we are considering document providers and documents and partitions in editors. The editors plugin defines its document provider as follows. Identifier org.eclipse.ui.editors.document providers. This extension point is used to define mappings between file types and document providers, so between types of editors, editor inputs, and document providers that can be used by editors. Document providers must implement the interface org.eclipse.ui.texteditor.iDocumentProvider. Edit inputs must be instance of org.eclipse.ui.iEditorInput. In the workbench, an editor is typically open when the user selects a domain element such as a file or an element stored inside an archive file, and it's open it. When the editor is created, it is associated with an editor input which describes the project being edited. Java edit example opens when the user opens a file with the *.java extension. In this case, the input to the editor is file editor input. The platform text framework assumes a little about the editor input itself. It works with the presentation model called an iDocument for the input so that it can effectively display and manipulate text. This means that there must be a way to map from expected domain model the editor input to the presentation model. This mapping is defined in iDocument provider. Given an editor input, the document provider returns an appropriate iDocument. Java edit example inherits the text file document provider defined by the plugin org.eclipse.ui.editors. The extension org.eclipse.ui.editors.document providers is used to define mappings between editor file types or an file extension and document providers. The editors plugin defines its document provider as follows here. The extension point allows plugins to register document providers and associate them with either a text with a file extension or an editor input class. Since the Java edit example does not define its own document provider extension, it inherits the generic document provider specified for all input types that are iStorage editor input. When the user opens a file for editing, the platform manages the details of creating a proper document provider instance. If a specific document provider is registered for the extension, that will be used. If there is no specific document provider for the extension, then the editor input type will be used to find the appropriate provider. By using the generic platform document provider, the Java edit example can take advantage of all the features of the document provider, such as file buffering and other optimizations. Now we are considering contributing a search page in search support. The following example is the JDT plugin's contribution of the Java search page. Identifier org.eclipse.search pages. This extension points allows a plugin to register search pages for specified searches. When the search action is performed on a resource, the search infrastructure locates the most specific registered search page for it. When the user selects a resource and chooses the search command, the search plugin launches a dialog containing pages for different kind of content searches. These searches are contributed using the org.eclipse.search pages extension point. Markup for contributing a search page is straightforward. Following example, JDT plugin's contribution of the Java search page here. The class that implement the search page must be specified. This class must implement iSearch page interface and typically extend the dialog page. The label and icon that can be used to describe search in the search dialog are also specified. Additional parameters control the size of the page and the location of the page within the search dialog. The extension attribute specify the resource on which the search page can operate. It is formed as a comma-separated file list or from a comma-separated list of file extensions. Each file extensions should be followed by a numeric weight value, where 0 is the lowest weight and separated by a colon. The weight value is the relative value used to allow the search infrastructure to find search page most appropriate for a given resource. If a search page can select all possible resources, then asterisk should be used. In some cases, now we are considering merging file types in compare support. The platform defines storage merger for merging three files of plain text. Of plain text. The identifier org.eclipse.team.co.storage merges. This extension point allows the plugin to register a storage merger for specific content types. The storage merge is expected to perform a three-way merge on tree input storage and write the result to an output stream. The extension point must implement the interface org.eclipse.team.co.mapping iStorage manager. In some cases, the ability to merge files without the assist of the user is desirable. The extension point org.eclipse.team.co.storage storage merges allows you to contribute a class that merges three different files of a storage unit into single output stream. Storage merges can be associated with the file extensions or bound to a particular content type. The platform defines a storage merger for merging three files of plain text. The storage merger itself is described in the storage merger element. You must specify ID of the merger and class that implements it. You may also specify the file extensions for which the storage merger should be used. You may also use the content type binding element to associate content type with the storage merger. Storage mergers must implement iStorage manager. This simple interface merges that contains from three different storage units into a single output stream. The not so simple implementation depends upon your plugin and its content types. Now we are considering extension point in repository providers in team support. Here is the markup for CSV client. Identify org.eclipse.team.co.repository. The team plugins contains the notion of repositories. The job of a repository is to provide support for sharing resources between team members. Repositories are configured on a per project basis. Only one repository can be mapped to a project at a time. The org.eclipse.team.co.repository extension point is used to add the repository definition. Here is the markup for CVS client. The registers this registers your team provider with the team support plugin and assign an ID that should be used when your provider is associated with the project. The specified class for the repository must extend the repository provider. Now we are considering adding launchers to the platform in launching a program in program debug and launch support. The following markup shows how the Java tools declare a Java launch configuration for launching local Java programs. The identifier org.eclipse.debug.co.launcher configuration types. This extension point provides a configurable mechanism for launching applications. Each launch configuration type has name, supports, name support one or more mods, run or debug, and specify delegate responsible for implementation of launching an application. As of 3.2, the types can also define a migration delegate that can be used to set resource mappings between projects and the launch configuration that launch them. Your plugin can add launch configuration types to the platform using org.eclipse.debug.co.launch configuration types extension point. This extension point allows you to declare configuration type using unique ID. You must provide the corresponding implementation of iLaunch configuration delegate The delegate is responsible for launching its launch configuration in a specified mode. Optionally, you can implement iLaunch configuration delegate 2, which enhances the delegate interface to allow you delegate to abort a launch, build relevant projects in the workspace before a launch, and control the creation of a launch object that is used in a launch. In addition to defining the delegate, you can specify which launch modes are supported by your delegate and a name that should be used when showing launches of this type to the user. Following markup shows how the tool declare a Java launch configuration for launching local Java program. This extension defines a launch configuration delegate that can be used to run or debug programs that are launched using local Java launch configuration. Now we are considering running and build file programmatically in platform and support. The following code snippet shows an example of how to use the Ant Runner from within the code of another plugin. The class Ant Runner entry point for running and builds inside Eclipse within the same JRE. Client may instantiate this class. It is not intended to be a subclass. This is in the package org.eclipse.ant.co. The Ant support built into the Eclipse allows plugins to programmatically run Ant build files. This is done via Ant Runner class, including the org.eclipse.ant.co plugin. Following code snippet shows an example of how to use Ant Runner from within the code of another plugin. In the progress menu, if the progress monitor is used, it is made available to the running available for the running tasks. Note that the only one build and build can occur at any given time if the builds do not occur in a separate VMs. Now we are considering defining an intro part in welcome in user assistant support. For example, the following contribution defines a hypothetical intro part to be shown by the workbench on startup. The identifier org.eclipse.ui.intro. This extension point is used to register implementation of special benchmark parts that are responsible for introducing a product to new users. An intro part is typically shown the first time a product is startup. Rules for associating an intro part implementation with the particular products are also contributed via this extension point. The iIntro part interface and the org.eclipse.ui.intro extension point make up the generic mechanism that can be used to create your own intro support for a given product. The main purpose of this extension is to define the class that implements iIntro part and to specify the binding between product ID and intro part. For example, the following contribution defines a hypothetical part intro part to be shown by the workbench on startup. This contribution first defines the intro part and assign into the ID some ID. It then binds this intro part to a product whose ID is com.example.some product ID. On platform startup, the class is specified in the class attribute will be instantiated by the workbench and presented to the user as the introduction to the product. This is the lowest level integration into the iIntro part interface. The platform supplies its own iIntro part called customizable intro part. that allows for the content and presentation of the intro to be customized. Below is the snippet that defined the intro part for the workbench. We won't go over the mechanics of the implementing intro part since we want to focus on defining the intro content. This contribution defines the customizable intro part as the intro part to be used for Eclipse SDK platform. The rest of here. Now we are considering operations API in API overview in provisioning platform P2. The following snippet shows sequence of updating everything in a running application. The class update operation. An update operation describes an operation that updates the installable units in a profile. The following snippet shows one of most used in operation to check the updates of the profile and then install them to the background. Actually, that snippet is not available. I didn't include that snippet. This is a different one. This is doing the sequence for updating everything in the running application. And this class is in the package org.eclipse.equinox.p2.operations. The operation API provides a high-level API for installing, updating, and installing software in a headless system. Operating API is defined with the progressive disclosure in mind. That is the simplest and most common operations require little knowledge of underlying concepts. Client work with the operation in two passes. The operation must first be resolved. Which means that the requirements and dependencies are calculated to determine if desired operation is compatible with what is already installed in the system. The operation can be resolved. Then the actual provisioning work, downloading an artifact, updating the system can be performed. The two-pass nature of an operation allows the resolution stage to be reported to a client to determine whether the operation should be proceed. For example, the client can determine if the resolution is acceptable or examine the detailed plan of what needs to be installed in order to continue with the operation. Resolution and provisioning phases can be performed synchronously or in a background as a job. The simple example can help demonstrate the simplicity of the operations. A common operation in many applications is to simply update an application to get the latest version of everything. This is possible with a very little code. The following snippet shows sequence of updating everything in a running application. If there's a problem resolving an operation or client code wants to something slightly different, then the little more code might be needed. For example, an operation can be configured to update an application that is not running application or to consult a specific list of software repositories for update. Inside the operation, the underlying P2i planner is performing the resolution pace and the underlying P2i engine is performing the actual install. However, these subsystems do not need to be understood by a client working with operations. For more information about operations, consult the Java doc for profile change operation. Code snippets for working with operations can be found in the Java doc for install operations, update operations, and install operations. Create an operation. We have the provisioning agent to be a provisioning agent. Resolve the operation to see if we can update. Result is okay. Get a job that will perform the actual work and schedule it. The preferred mechanism here now we are considering products extension point in defining product in packaging and delivering Eclipse based products. Here is an extension definition found in the org.eclipse.platform. The identifier org.eclipse.core.runtime.products. Products are the Eclipse unit of branding. Products extensions are supplied by plugins wishing to define one or more products. There must be one product per extension, as the extension ID is used in processing and identifying the product. The preferred mechanism for defining a product based on the Eclipse platform is to contribute the org.eclipse.core.runtime.products extension point. To do this, a plugin simply declares the name and the ID of its products, as well as the ID of the application. Extension that should be run when the product is invoked. This is the technique used by Eclipse platform itself in defining the Eclipse product. Here is an extension definition found in eclipse.platform, org.eclipse.platform. A product extension is defined whose application ID is org.eclipse.ui.ide.workbench. This is the application ID defined by plugin org.eclipse.ui.ide on its contribution to org.eclipse.core.runtime.applications extension point here. This extension is defined with the same ID that is referenced in the application. Application property of the product extension. The fully qualified name with the plugin prefix is used when referring to the application ID from the other plugin. Using this mechanism, a separate plugin can define all the product's specific branding and then refer to the existing plugin's application as the application that is actually run when the product is started. In addition to the application, the org.eclipse.core.runtime.products extension describe products customization properties that are used to configure the product's branding information. This information is described as name properties. Let's look again that the portion of markup for platform plugin. The possible property names are that are honored by platform for product customization are defined in iProduct constants. Now we are considering building a rich client platform application. The minimal set of plugins needed to build a rich client application is collectively known as the rich client platform. While the Eclipse platform is designed to serve an open tools platform, it is architected so that the component could be used to build just about any client application. The minimal set of plugins needed to build a rich client application is collectively known as rich client platform. Applications that don't require common resource model can be built using a subset of the platform. These rich applications are still based on the dynamic plugin model, and the UI is built using the same toolkits and extension point. Eclipse RCP applications are defined to use the dependency injection and a server-oriented architecture. The Eclipse renderer framework allows to control the appearance of the default user interface, and clients can use either default renderer for SWT or custom renderers for other UI technologies. Eclipse platform provide the E4 applications as a default entry point, but clients are free to create their own application. Rich client applications are free to use any API deemed necessary for their future set and can require any plugins above the bare minimum. Now we are considering HTTP service and JSP support. The platform SDK comes packaged with org.eclipse.equinix.http.jetty, an implementation of OSGI HTTP service that uses Jetty as its underlying servlet container. The package org.eclipse.equinix.http.jetty provides core support for the Jetty-based HTTP service. Equinix provides support for building and running OSGI-based web applications both inside RCP and application server environment. In an OSGI web application, use the OSGI HTTP service replaces the use of web.xml deployment file. The HTTP service providers means to register servlets and resource in a manner more consistent with dynamic environment in Eclipse where bundles can come and go. The platform SDK comes packaged with org.eclipse.equinix.http.jetty, an implementation of OSGI HTTP service that uses Jetty as its underlying servlet container. This implementation allows customization and configuration of many of the server settings important for integration. Java server pages play a central role in many Java server environments, allowing the presentation of dynamic content on-the-fly compilation of JSPs is provided by org.eclipse.equinix.jsp.chassis JSP servlet. Now we are considering API reference in reference. The package org.eclipse.ant.co provides support for running the ant build tool in the platform. Now we are considering extension point reference and properties and in ant properties. Identifier org.eclipse.ant.co.ant properties allows plugins to define ant properties for use in ant build type file. Now we are considering platform runtime available OSGI services interfaces to extend the customize the platform. org.eclipse.co.runtime.iadapter factory services contribute adapt strategies similarity to extensions of org.eclipse.co.runtime adapter. Interface iadapter factory. An adapter factory defines the behavioral extensions for one or more classes that implements the adaptable interface. Adapter factories are registered with an adapter manager. This is in the package org.eclipse.co.runtime. Now we are considering OSGI 7 core API reference package org.osgi.dto. Bundles wishing to use this package must list the package in the import package header of the bundles manifest. This package has two types of users: the consumers that use the API in this package and the providers that implements the API in this package. OSGI Compendium Release 7, the package org.osgi.application. Bundles wishing to use this package must list the package in the import package header of the bundles manifest. This package has two types of users: the consumer that use the API in this package and the providers that implement the API in this package. Now we are considering OSGI Enterprise Release 7. The package org.osgi.jmx. Bundles wishing to use this package must list the package in the import package header of the bundles manifest. This package has two types of users: the consumers that use the API in this package and the providers that implement the API in this package. This is OSGI JMS package version 1.1. Now we are considering Eclipse, the command line arguments in the Eclipse runtime options. In other reference information, the dash application ID runtime, the equivalent to settings eclipse.application to ID. Now we are considering adopting job manager implementation changes, possible deadlock in iJob change listener. In adopting 4.26 mechanisms and APIs in migrating to Eclipse 4.26 from 4.25 in plugin migration guide. Attention, the job manager implementation was changed. The all job manager implementation notified iJob change listener. uh, about the various iJob change event without strict order in various threads. For example, schedule was scheduled method was called thread that did call schedule on the job, while done is normally called within the worker thread. In this case, repeated schedule both schedule method both notification could run in parallel. This was a race condition. The listener could not deterministically know if the job was still scheduled or already done. As a consequence, the join method could have returned too early, or the progress view did not show jobs that did still run, and probably many other things went wrong totally unnoticed. Even multiple notification could have happened in parallel in various worker threads, as there is no guarantee that the next execution is done in the same worker. To fix the indeterministic behavior of all events for the same job instance will now be sent one after another. With it is still not defined which thread jobs event will send, but new implementation will not call any iJob change listener until pending events for some job instances are processed by all registered iJob change listener. The new implementation will also wait with any job state until when it state change until all calls to iJob change listener for that job returns. The iJob change listener Java clearly specify whether the change state occurs before, during, or after listeners are notified is unspecified, and the implementation change within that broad specification. Unfortunately, some iJob change listener around rely on the old implementation. They may now deadlock. For example, the following code snippet can now deadlock. Instead, use this. The same problem may occur in all job iChange listener methods and all methods that result iJob change event being called. iJob change event being sent. The job schedule cancel and wake up and sleep, and job manager shutdown. The make sure all iJob listener change listener implementation do not block the return promptly. Due to the extreme risk of new implementation, tries to identify non-conforming iJob change listener and do all fallback. When an iJob change event is not handled within 3 seconds, a timeout error is logged in a stack trace of completing threads of job manager will no longer wait until JVM is restarted. Further calls to iJob listener may occur in non-deterministic order, and job manager join family can return too soon. It is, however, possible that there may also be some deadlocks in client's code due to change job manager implementation that may be undetected by job manager. Also note that it is undefined in which thread iJob change listener methods are called. Clients may have relied on the old implementation which called done in the UI SWT thread for UI job, but that is not the case anymore. It may happen in a background thread. It is recommended to check existing iJob change listener implementation for possible regressions if updating to the new target platform. Lock needed for reasons. Okay. May result in done. Lock needed for reasons. Schedule will notify scheduled, which may not return before previous notification returns. Can not enter while other threads hold lock. Possible deadlock. This plugin load error java.lang null point exception. Now this is the end of my presentation. Thank you very much for watching it.